The last section in Chapter 6 takes all the different types of factoring that we've talked about and helps us decide when to use what. On the test, it's just going to say factor or factor completely, and you have to know what you're doing. So these are the different types of factoring techniques that we've done so far. So the first one was factoring out a GCF. So we take a look at that thing. We can see that all of them have a 3 in common. So that's something that we can take out. We'd have left x squared plus 5x minus 2. We should check to make sure that that other thing cannot be factored. So are there two numbers that add to make 5 and multiply to make negative 2? And there's not. So this is done. We just took out a GCF. The second thing that we did was factoring out a common binomial. So this is still kind of a GCF because remember this was one term and this was another term, and both of those terms have an x minus 5 that we can take out. And when we factor that out, we're left with 8 plus x. So that was all in one section. And then we did grouping, the opposites, and the whole diamond puzzle thing. So remember, in order to factor by grouping, you have to have 4 terms. We can make 4 terms, but you have to have 4 or other even numbers so that you can group things together. So in the first one, 12a cubed minus 9a squared, they both have a 3 in common, and then they also have a squared in common that we can factor out. So when I take those out, I'm left with 4a for the first term, and then minus 3 for the other one. And remember, the whole goal of factoring out this second group here is to end up with the same thing in parentheses so that we can do something like number 2, factor out a common binomial. So out of 20a and negative 15, they both have a 5 that I can take out. And if I divide 5 out of 20a, I'm left with 4a. And divide 5 out of negative 15, I'm left with negative 3. And then just like the number 2 before it, we can turn this into 3a squared plus 5 times 4a minus 3. So factor by grouping uses factoring out binomial. You just have to get it so that they have a binomial in common. So then the next one we did was the whole opposite thing. So we're still running with the whole common binomial, except in this one, they're not exactly the same. They're pretty darn close. We have an x minus 3, and then this one's a 3 minus x. So we need to remember that we can turn 3 minus x into negative 1 times x minus 3. And because of that, we can turn this into, this one's going to stay the same, negative 1 times x, or negative x times x minus 3. And now this looks like the last two problems we did, both number 2 and number 3. They both have the same binomial in common, so we can factor that out. They have an x minus 3. And then when we take that out, we're left with 8 minus x. So almost all of those ones have to do with finding a GCF first and then factoring out a common binomial. Then we moved on to 8.3 and 8.4, where we had the whole diamond puzzle. We want two numbers that multiply to make the number on the end, and two numbers that add to make the number in the middle. So the first type, number 5, was the easy type. And in this one, your a value, or your number in front of x squared, is 1. So that means we don't have to do the box thing. We don't have to do the factor by grouping. All we have to do is come up with two numbers that add to make negative 3. And those same two numbers have to multiply to make negative 40. So those numbers are going to be negative 8 and 5. And then we know those are our factors. X plus 5 times x minus 8. This next one, though, we have a number in front of our squared term, so that makes it a little more difficult. We want to either factor this one by grouping, turn it into the box, or that new little method that I showed you earlier. I'm going to do that one just to make sure that everyone kind of knows what's going on with that one, and maybe if you didn't catch it in class, it'll make a little more sense in the notes. So because I see this number here, I want to multiply it by this, just like before. But we're going to turn this into negative 60. Now this isn't the exact same problem, but it's one very similar that we can use to help find the answer. So the first thing I want to do is set up my diamond, just like before. I want two numbers that add to make negative 11, and multiply to make negative 60. So the two numbers that do that are going to be 15 and 4. And I want 15 to be the negative 1. So this problem right here was the one I would have given you. The answer would have been n plus 4 times n minus 15. But because it wasn't, because it had that 6 out front, this is where we need to remember that and divide by 6. And then you simplify the fraction there. 4 over 6 can be simplified to 2/3. And then your number on the bottom becomes the number in front of your n, and the number on top stays there. So this is really 3n plus 2. And then do the same thing here. 15 divided by 6 can also be simplified. 3 goes into 15 5 times, and it goes into 6 twice. So remember, this 2 comes up here. So this becomes 2n minus 5. Now you can always double check that that's really what needs to happen in order to get the trinomial that you started with. If you don't like that way, hopefully you figured out the same exact answer using any of the other methods that we've done. So that was all of 8.4. That's what we took the quiz on Tuesday. So 7 and 8 were what we did in 8.5. And those ones are ones that you can solve exactly like 5 or 6, but they're a little easier if you remember the tricks about perfect squares and then the difference of squares. So remember, you want to look out for something squared on both ends, and then if it's squared, figure out if double times those squares gives you what's in the middle. So what would I have to square to get this? It would be 2x, and this one would be 3y. And then you double check if I multiply 2x times 3y times 2, if that gives you 12xy. So 2 times 2 gives me 4, times 3 gives me 12, and then x times y gives me xy. So now I know this is a perfect square. So I'm going to take these two things that I found here and use them to make my factors. So this is 2x plus 3y all squared. Remember, you can do this exactly the same as the other ones. It's just going to take a lot more time. And then finally, the difference of squares. So this one, you notice two things being squared. In this case, it's 11a. And in this case, it's 7b. You notice that there's subtraction in the middle. So that means that you had to have a middle term that crossed off. So we're going to use those two things, 11a and 7b. You're going to make one positive and one negative. So hopefully all of that was review. So now, when do I use these things? So, knowing when to use them. Any polynomial, you should always check for the GCF. Remember, that is something we need to do no matter what. So whether it's a binomial, trinomial, or it has 4 or more, always check to make sure that it has or doesn't have something that you can factor out of everything. So if it is 2 terms, we have 2 options right now. Either it's just a GCF problem, or it's a difference of squares problem. So remember, the difference of squares was number 8 down here. So those are your two options if it's a binomial. If it's a trinomial, look for a GCF. Sometimes that's all you can do. Look for the perfect square pattern. So you have two things squared on the ends. Or you could do the diamond puzzle pattern and solve it any of the ways we've done. The factoring by grouping, or the box, or the little trick I taught you earlier this week. If it has 4 or more terms, look for a GCF. Again, sometimes that's it. And then factor by grouping. And remember, in order to factor by grouping, you have to have an even amount of terms so that you can break your groups up evenly. So here's a bunch of problems. I'm just going to go through, figure out which way to do them, and then I want you guys to solve them all. Make sure that you can practice all of those different ways. We'll go over the answers in class. So, first thing I noticed, this is a trinomial. So that means I have a couple options. Find a GCF, look for a perfect square, or do the diamond puzzle. So, is there a greatest common factor? Take a look at all those numbers. They're all even, so we can pull out a 2 for all of them. So once we do that, we're left with 5x squared plus 24 plus 16. And then, once we're done with that part, then we have to check to make sure that there's not a perfect square pattern, and we can't do the diamond puzzle before we can say we're done. So we want to ask ourselves, is this a perfect square pattern? This right here is not something perfectly squared, so we can cross that one off. Totally not an option in this. And then we want to look for a diamond puzzle pattern. So we're going to need two numbers that multiply to make 5 times 16, which is 80. And those same two numbers have got to add to make 24. And after you think about this for a while, there are two numbers that work, 4 and 20. So because we can find these two numbers, we have to keep going. You need to break this down into 2 more factors. So I'm going to stop this problem here. You guys continue on and we'll discuss it in class. Go ahead and pause the video while you work on it. So next problem. Again, it's a trinomial, so we are looking in this box and this box only. First thing you always look for, is there a GCF? 2, 5, and 4. Can't pull anything out, so that one's out of there. Is it a perfect square pattern? The end is, but this is not. There's nothing I can square to get 2. So that's out of there. The only thing we have left is a diamond puzzle. So we have to ask ourselves, two numbers that multiply to get 8 and add to make 5. So the numbers that multiply to make 8 are 8 and 1, are 2 and 4, and none of those add up to make 5. So, because those are our only options, the answer to this problem has to be not factorable. Moving on. So this one is a binomial. So binomial, we're right here. First thing we gotta look for, is there a greatest common factor? There definitely is. 8 and 18 are both even numbers, so we can take a 2 out of both of them. There are 2 x's that we can take out of both of them, and 2 y's that we can take out of both of them. And then we'd be left with just a 4, x to the 4th, not x squared, x to the 4th, minus 9, and that's it. And then always double check that nothing else can be factored inside of here. So again, we have a binomial. We already pulled out the GCF. The only other option is a difference of squares. And these two things are something squared. 4x to the 4th is really 2x squared, all squared. And 9 is really 3 squared. So this part right here can be turned into 2x squared plus 3 times 2x squared minus 3. And then we have to remember that we pulled this out in the beginning, so this also needs to be a part of our answer.